Hello everyone. Today I will be presenting our project on the RFID Smart Parking Management System. And this project aims to tackle the parking challenges by utilizing the RFID technology to improve the efficiency and accuracy in the parking management system. So let's dive in. And this is the outline today. So we will start with the project background first, and then we'll follow the concept and technology behind it. And then we'll look at the system architecture, and then the operation flow. And before exploring the unique features of our solution, and we'll compare it with the current solutions, discuss future development possibilities, and the conclusion. And now, let me share with you the system we have deployed. So this is our parking background. So parking management is a widespread challenge in urban areas, and the key issues is included insufficient parking spaces and difficulty in finding the available spaces and the time-consuming entrance and exit process, and causing the frustration for many drivers. And currently, most parking facilities rely on the camera-based license plate recognition systems. And however, this system often struggle with lots of problems, such as the vehicle and the trucks or vans where the license plates are dirty and obscured by mud or covered by dust, and resulting in poor recognition accuracy. So to address this issue, we have developed an RFID smart parking system to capable the guiding drivers to vacant spots, and particularly focusing on providing accurate parking availability data and streamlining the entrance and exit process for users. So our solution leverages the RFID technology, which allows to track vehicles with RFID tags on their license plates. And not only we have installed the RFID readers at the entrance and exit for the parking lot, but we also deploy them in the vacant parking spaces within the lot. So, this has several advantages. It is fast, efficient, and accurate. And the RFID tag enables the system to detect cars without additional inputs from the drivers. And the data is instantly updated in our backend and improving the overall parking experience. So this is our high-level overview of our system architecture. And the system includes the RFID readers installed at the entry and exit points and the parking lot spaces. And the backend database stores vehicle and parking data, and the user interface for users to view the real-time information. And the RFID readers communicate with the database, which then sends data to interface and allowing the users to see the available space and navigate directly to them. So now let me introduce our main point, RFID, the radio frequency identification. So it uses radio waves to identify objects and track their movement. So in our system, the vehicle has an RFID tag on each license plate. And when the vehicle enters or exits, the RFID reader picks up the tag information and logs it in the backend database. So this method is precise and only identify the vehicles, avoiding the interferences from other moving objects. So it ensures the reliable detection regardless of the clean lines of the license plates or the environmental issues like lighting conditions, and enable accurate vehicle entrance recognition. So let's talk about the reader. The RFID reader, it is equipped with a built-in high-sensitive 7.5 dBi antenna and the 28.2 dBi RF module. It supports the RS4, A5, and Weekend 34 interfaces for long-distance communication with the terminal devices. And additionally, the design feature low power consumption for energy efficiency and align with the environmental trends for energy conservation and the carbon reduction. So it is suitable for applications like parking management and across control. And the RFID tag is utilizing the UHF, what is called Ultra High Frequency Electronic Tags. And this is current mainstream technology. It is compact and cost effective and a read-write distance up to 10 meters. And it offers a strong penetration capability and fast data transmission speed. So this is our system functionality. On the front end, the user interacts with the monitor at the entrance, and upon entering the parking lot, it shows the real-time information on the available spots and guides recommend the driver to the designated spot. So this process reduces the time consuming and searching for parking space. So, and I will provide a detailed explanation for the user interface on later. And the backend is responsible for data storage and processing. So when a vehicle enters or exits, the RFID reader sends the data to the backend database and updating the vehicle's status and the spot availability in the real time. So this architecture ensures the users always see the accurate information on the user interface. And as you can see, our backend database maintains a complete record of information such as the license plate, entry time, exit time, and the parking fees. So this slide shows the entry and exit flow. So when a vehicle entrance, the system reads the RFID tag and then immediately detects if there are any available spaces in the parking lot. And if there are no spaces, the interface will show the waiting message, the green square as you can see. And if there are available space, it records the time and assigns an available spot. And when the vehicle exits, the system reads the tag again, and then deletes the data from the database, and then calculates the total time parking fee, and after that, it will automatically update the available parking space from the backend and display the thank you message on the user interface. So this process is smooth and automated and requiring the minimal interaction from the users. And now I would like to introduce the features and functionalities of our system. So one of the key advantages of using RFID of empty spot detection is its accuracy. So as I mentioned before, most parking facilities rely on the camera license plate recognition system or the sensor system. But this system often causes a lot of problems, like the plate is dirty or covered of the mud, something is bad accuracy. And in fact, most parking systems currently on the market primarily rely on those systems. And the RFID system is a supplementary measure. So when the license recognition fails, the reader is used for a backup. And in the parking area, unlike the cameras and recognition, geomagnetic sensors as well, the RFID technology only detects the vehicles with the tags, and then avoiding the false reading due to the pedestrians or the moving objects, and this makes our system more reliable and precise. So I want to introduce our automatic billing feature. So our automatic billing system calculates the parking fees based on the entry and the exit time recorded by the RFID reader. So as you can see, once the entry time is recorded, the system starts to calculate the duration until the exit time is detected. And currently, we have not yet integrated with a bank account. So our system only calculates the parking fee. But of course, the fee structure can be modified according to the pricing rules or set by each parking lot operator. So the $30 is only for demonstration purpose. So this automatic system eliminates the need for manual billing and improving the both accuracy and convenience. And next, I would like to highlight our key features of our system, the user interface. So when the lot is full, the parking full, please wait message will appear on the entrance display and prompting the driver to wait until the spot opens up. And if parking spaces are available, the screen will display a welcome message, of course, and the entry time. What's more, our feature, it will show the map and recommend the driver to the parking area we recommend. So this feature represents the key difference and innovation compared to existing system on the market. And then when the driver is ready to exit the parking lot, the screen will display a personalized thank you message and along with a summary of the total parking fees and calculated based on the duration of the stay. So this interface saves the user's time and simplifies their parking experience by providing the clear directions and streamlined payment process.
When the driver enters the parking lot, the app will display the map and available parking spaces. When a vehicle parks in a space, the number of available spaces will automatically decrease by 1. When the driver exits the lot, the app will update the parking space as vacant and increase the number of available spaces by 1.
So now let's see the system testing and results. So we really collaborate with the industry partners to install the RFID readers in the parking lot entrance and the parking area. So we conduct extensive system testing to evaluate the accuracy and efficiency of our RFID smart parking management system. So our results indicate that a 98% accuracy in detecting vehicle entrance and exit with the minimal delays. And for visual and vision height updates, the computer and the digital lighting capabilities are required in the case of license plate recognition technology. However, this shows down the license plate recognition per second. The license plate recognition, the system can detect like 100 miles per hour, but which is lower than the UHF RFID technology recognition, which works over 150 miles per hour. And our system addresses the limitation of traditional systems, which can sometimes misinteract other objects and vehicles. So with the RFID system, only vehicles with a text trigger a response and resulting a precise parking status data and preventing users from seeing the accurate parking availability. And our RFID reader solution has unique advantage of the existing systems, such as cameras and geomagnetic sensors. So by focusing on the RFID tag, our system avoids false positives and achieves a higher accuracy in space detection, which is essential in busy urban areas. So in the future, we plan to expand our system by incorporating the additional features like developing an actual app we're still developing, and the functions including the parking space reservations and the predicting parking availability. So as mentioned earlier, we aim to collaborate with the banking institutions and eliminating the need for payment machines. Instead, when a vehicle exits, the system will automatically detect the vehicle information and charge the linking account, and embodying the concept of IoT, Internet of Things. So additionally, by integrating to AI, we predict the parking trends and utilizing the big data analysis, we can further reduce the congestion and improve the user satisfaction. And our cost and benefit analysis shows that the RFID system has an affordable setup cost compared to camera and geomagnetic system. And the benefits such as reduce congestion, time saving for users, and enhance the parking efficiency. Outweigh the initial investment, making this a cost-effective solution for large and small parking facilities. So the future potential of this RFID reader system is vast. For example, we can integrate it with the small city infrastructure to enable dynamic parking availability updates across the city. And furthermore, using this technology in combination with the autonomous vehicles could streamline self-parking. And in addition to parking applications, we also envision extending the RFID to areas such as the office buildings, large shopping malls, retail, warehouse, logistics, and even the healthcare. So with a lot of application, with the ongoing decrease in the RFID technology costs, I believe that the widespread adoption of this system is highly feasible. So in summary, our RFID system provides an efficient and accurate parking solution. So by using the RFID technology, we address a common issue in existing systems, like difficulty in finding available spaces, and the completely entry and exit process, and making the parking more environment user-friendly. And next, I will put a video demonstrating the real-world application of our system in the market. Let's take a look.
The RFID Smart Parking System. Now let's take a closer look at the system's actual application. First, when a vehicle approaches the parking lot entrance, the entry RFID reader automatically detects and reads the license plate tag, identifying the vehicle. After receiving the license plate information, the system immediately checks if any spaces are available in the parking lot. The RFID readers installed within the parking area continually monitor space availability. Each reader can detect up to 4 tags representing parked vehicles. If a reader detects no tags, this indicates that spaces are available in that section. Conversely, if tags are detected, this signals that there are no available spaces. When the lot is full, a parking full, please wait message appears on the entrance display, prompting the driver to wait until a spot opens up. If parking spaces are available, the screen at the entrance displays a welcome message and recommended parking area, helping the driver find a spot quickly. The vehicle then proceeds into the lot and is directed to an open space based on the recommended parking area calculated by the system. This ensures an organized and efficient process, minimizing congestion and enhancing the driver's experience by providing clear instructions. When the driver is ready to exit the parking lot, the RFID reader again identifies the vehicle's license plate. The screen then displays a personalized thank you message, along with a summary of the total parking fees calculated based on the duration of the stay. This automated exit process ensures transparency, convenience, and speed, making parking management more streamlined for both the facility and the user. The effectiveness of our RFID technology significantly enhances parking management systems. Its superior accuracy, quick response time, and reduced error rates make our RFID a practical solution for addressing the challenges of urban parking.
So thank you for attention. So this is our presentation. Thank you.
Thank you for the insightful presentation. Now we might open for Q&A section for all judges.
All right, Nick and Alex, first of all, it is very interesting system implementation. You show how to actually implement your system in practice. Okay, so I have some comments about your presentation. First of all, Alex, you should not use your smartphone during the presentation. Okay, so just remind everyone in the future when you have the presentation, do not use your smartphone. Okay, so you should be confident to present your speech, okay, without looking at your smartphone. So second one, Nick, since you already use some hardware, for example, RFID reader and RFID tag, you should bring the hardware in your presentation to show the OD what is the RFID reader and the tag looks like. Okay, so this is going to improve help the readers to understand what is your system implementation. Okay, the third one, I'm just curious about, so right now, many car parks the parking system are using the camera to detect the vehicle enter and leaving the car parking, and also we can get the car park space on the parking space, right? So I just want to ask you, what is the significant difference between the RFID system and the camera, the detections, the system, the parking management system? What is the difference?
So the camera and the camera-based license plate recognition is it uses a camera to sense the license plate. Use the big data analysis to read out this letter is A or B or C or 1, 2, 3, 4. But in our system, our value system, it uses the tag. So we don't need anymore the camera. So we just use the radio waves to detect the RFID tags, and no matter the environmental issues, the lightning or the dirt, dirty or mud, something, we can directly to detect the tags and then get the information to our user.
Yeah, it is true. But do you think about, if that is, so that means every vehicle must install RFID tag on the plate, right? So it is possible for, in my opinion, for your system, it is better for the small communities car park management system. Or for example, all of the community members are allowed to use the car park, so you can install the RFID tag on the plate. But for the commercial, for example, shopping mall car parking system, so you cannot. It is impossible to install the tag on all of the customer vehicle. Is it right?
Yeah. So in today's smart society, not every vehicle install the RFID tag. So innovate this system to our market, and with the cost decrease. So I think this technology and system will be so widespread in the future.
It is possible. It's possible. But then this is this is why right now you are right. The APR is the video readers to detect the vehicle plate number. Somewhat we have some problem detection the inaccuracy problem. But right now it is we can overcome these issues easily. Okay, so this is just a question about the innovation of the system. But it is true, the RFID system, the current management system, it is the material, the technology probably used before. But I suggest you maybe think about how to combine RFID system with the region management system together.
Okay.
So, and lastly, I have another question about you show me you have the map on the system to guide the driver to go to the available parking space, right? So what is the map that is going to be? It is on the vehicle or it is on the display on the car park space?
Yeah, it will display on the user interface.
So that means the user needed to install the app.
No, we're developing the app in the processing, but we have also the map on the user interface on the parking lot entrance, the marker, the welcome entrance time.
Okay, I understand. But in practice, many people have the same experience. When I'm driving into the car parking, I know we have some, for example, 5, 6 car park space like that. But when I drive there, the space occupied already by the other customers. So it's better for your system to provide real time the car park space available right now. Okay, so you can also investigate to navigate the customers to get the available car park space quickly. So this is going to reduce the customers finding the time. Okay, so this is my suggestion. Think about how to improve your system. Okay, right? Thank you. So yeah, Dr. Lee.
So here, first of all, thank you for the presentation. Right? I also have similar question to our director. Okay. But first, I want to say that this is a very good topic. I think very useful. Solve a daily, everyday problem. Yeah, because I have this same type of problem, especially for drivers, right? so they always try to find the parking space, find the available parking space, and also try to get to one. And sometimes, yeah, currently right now out there, right? Sometimes they have sensors, but then sometimes it's wrong. Even it says it's screen is available, but it's actually not available. So yeah, those are problem for our everyday driver. So I think this could be this should be a good direction to research. Okay. And so also first the simple problem is I also wonder like how you get everyone to get install the RFID tag onto your car, because currently most of the time nobody has it, and especially in the public parking lot. Right. So probably in the beginning at least it should be like in combination in addition to the current system. Maybe you have also the RFID system. Maybe you can become an entrance or something and install these tags. So that could be one way. Okay. Another question I have is let's see. You talk a lot about how the ID, the tag, the technology right now, in comparison with the current technology cameras or the other technologies that use right now. Better in almost every way. But have you looked into any limitation or disadvantage for ID right now?
Disadvantage, okay, so far. Maybe one of the disadvantages that maybe the RFID tag is damaged, so we can't detect the value and correct correctly. So I think it's one of the little part, but compared to the camera system, I think it's the most benefit than the camera system.
Okay. All right. Thank you. And one other thing is I also looked through your documentation. Okay, so you have a lot of references, okay, but I don't see a lot of citations in your document. I don't know if it's
Okay, I will modify the documentation later because it's only for the first documentation. We'll modify it later.
okay. All right. Thank you. That's all.
Thank you.
As there is no question, thank you for your presentation and thank you for the feedback. Now let's move on to the next group.